With Sentry, we want to do more than just tell you when something breaks inside of your application. We want to give you the tools to be able to debug that application so you can figure out when it broke, what exactly broke, how your users are impacted, and give you the tools to be able to understand the root cause and how you can get it back up and running. My name's Cody, and in this video, I'm going to show you how you can use Sentry to debug a full stack application. Let's jump in and check it out. So here we are inside of my Unborked marketplace, and if I come up and do a refresh, we can see the application is starting to have some problems. If I go in and click try again a few times, we can see over and over again, it's just failing to load the products. Now I've got the Sentry dev toolbar installed, so I can come in here, click on issues, and I can see all the issues that are popping up inside of my environment. We can see a few seconds ago, we had a notification of an issue. If I go in and jump in, it's going to drop me right into that issue inside of my Sentry environment. Now, if I take a look at this activity bar on the top, I can zoom in on the specific range, and I can see there was a feature flag change recently done inside of this environment. And if I scroll down, I can see that feature flag is showing up as a suspect flag. So Sentry is detecting that that feature flag is part of the problem. Now, my favorite thing to do inside of Sentry is come up here into Seer, click on this find root cause, and tell it to start running this autofix. Now, what this is going to do is it's going to take all the context of my application, stuff from GitHub, the traces inside of Sentry, stack traces, and feed all of that into Seer to help understand what's going wrong inside of the application. It's going to produce a root cause, and it's going to help me fix it. Now, this is going to take a little while to run because, again, it's going to collect all of that information. And I could stay here and watch it and see exactly how it's thinking along the way. I could even jump in and contribute to it by feeding it more information about my application that I know, so it ends up being like a partnership of trading information to come up with a solution. But I'm going to let this run while we dig into some of the problems inside of the application. So I can scroll down here and I can see the stack trace for exactly where inside of my code this problem's happening. I can even see a replay that shows me exactly how the user was experiencing this problem when it showed up. So I come in, I refresh the page, and the error ends up popping up. But if I scroll down further, I can see the traces view inside of my app. If I jump into this, I can see exactly how the communication flow happened when this problem showed up. So in here, I can see the page started to load fine, but ultimately when it got to the backend server and it tried to run this product query path, it had a problem. If I expand this out, I can see the exact API call that happened, and I can see the connection out to the database as it tried to reach out. Now this is a Postgres database running at Neon, and what's really cool about this is because I've instrumented tracing, I can see all the way down to the database query that was actually happening. So it's really useful for understanding the performance of databases and when things go wrong. I'm going to jump back into my application and head back into the dev toolbar and check out my feature flags. I can use the feature flag integration inside of Sentry to disable this feature flag just for me to test it out. So when I turn this off and hit try again, we can see it successfully connects. So I can tell already that that feature flag is part of the problem and that there's something going wrong inside of it. Now I'm going to jump back into Sentry, and I'm going to go into this Explore tab and dive into my database queries from a tracing standpoint inside of Trace Explorer and see what I can find. So I'll come in here and I can do a bunch of different queries, but in this case, I'm going to use a span operation for the product list query. Now, what this is a custom span that I've instrumented inside of my application for all of my API calls. This one is the product list calls, and by coming in here, I can see all of the different versions of it that I'm calling. I'll jump into this span specifically, and I can see a lot more information. Now this one shows some of the failed queries, but it also shows the successful query down here on the bottom. So when I expand this out, we can see it was successfully calling the products endpoint instead of the product query endpoint. And in here, the database call is actually calling select star from products instead. So the failing query was calling a completely different database call entirely. So just by being able to see the trace, I can watch the communication flow, those queries, and I can see the difference here. Let's jump in and take a look at what Seer was finding as far as the problem goes. So go back into the issues view. We'll jump back into our original issue, and we can see that AutoFix has found a solution. Now from a root cause standpoint, I can come in and I can tell that the goods product query feature flag was enabled on my endpoint, but that was making it query a non-existent goods database table, causing that 500 error. I can see all of the different parts of the root cause that it found along the way to help it determine this. And again, I could come in here and feed additional information to change that if I wanted to. Now it's found a solution down here on the bottom where it's telling me to modify the product query endpoint to actually use the products table instead and to use Drizzle ORM to do it, since I'm already using Drizzle inside of the project. I can come in here and tell it to code it up, and it's going to actually build out the solution for me. While this runs, something else that's really cool is I can come in and I can grab this solution as Markdown, and I can actually feed that into an LLM inside of my editor and have it help me solve it if I wanted to. So we make it really easy to take all of this information that AutoFix and Seer are gathering for you and pull it out to use in the tools that you want to also. Ultimately, what we want is to be able to fix your application any way that's possible. So it's already presented out that code change here, and if I expand this out, we can see that it describes out removing those existing calls, adding in the drizzle calls specifically to call the products endpoint, which is the right way to do this anyways because it gives us type safety and all of that good stuff. And I can even come in and have it draft a PR to go ahead and make this change for me. So when I come in and draft this PR, it's going to go out and open this against my GitHub repo for this application. I'll go ahead and open up this PR, and we can see inside of GitHub that AutoFix and Seer have gone and opened up this PR for me. When I jump in and look at the file changed, we can see it's making the changes it recommended inside of the application already, and I could go ahead and merge this at any point and have the issue be fixed. Sentry is all about giving you the tools to be able to debug your application problems and get them back up and running successfully. In this video, we showed using Seer to go in and completely understand a root cause of what broke our application, but also how to fix it and pull a PR to get it back up and running. We also use the Trace Explorer to dive into traces and understand exactly where in our application's communication flow things broke down. And we were able to use the feature flag integration inside of the dev toolbar to disable that feature and test it out locally to make sure we could get back up and running. If you have any questions, we'd love to hear from you and help you get up and running. Talk to you soon.